All right, guys, let's jump in. We've got a new unit here. Let's take a look at what we're doing. This is the factoring unit. This is a fun part of algebra. This really is a big core component of your algebra, and I enjoy doing this. This stuff's fun, and it leads right into the quadratics unit we'll also be doing soon. Here's a couple examples on this page of what factoring does and what it looks like. The green is, actually, nope, the colors are mixed. Up here we've got something you would distribute and what it becomes. Well, we're going to learn to do the opposite. We're going to take that final answer and move it back into that distributed form. And same thing on the bottom. We're going to be able to go back and forth from distributing to pulling that back out and reversing your distributing. That type of factoring is called greatest common factor type. Let's look at it. Okay, first of all, what is factoring? What are we talking about? Factoring is breaking an equation or expression down into smaller and simpler pieces. Okay? It's in smaller and simpler pieces, often so we can find the solution to the equation. Okay? So what we've been doing for a while lately is distributing, multiplying binomials and polynomials and using FOIL, and we end up with bigger, more complex answers. For instance, this one here, this unfactored problem right here, what would happen if we factored it? What would it look like? Well, that problem factored would actually be rewritten as an x minus 3 and an x minus 4. And hopefully that looks familiar. This is the FOIL problem we just learned in this last unit. You just took a quiz on that today. Okay? So that becomes this unfactored larger trinomial answer when you FOIL them together. This is a different type of factoring we'll also learn. It's called trinomial factoring. And the idea here is, notice, this is kind of complex. If I asked you to solve that and figure out what x equals, that would be tough to do. I'm not sure, looking at that, if that whole equation equals 0, what is the answer for x? I don't know. But if we look at this factored form, it was broken down, things are simpler. And if it's still equal to 0, then it turns out we can look at each of those separate pieces and say, oh, well, x minus 3 is one of the two factors equal to 0. X minus 4 is the other one. And all of a sudden, I bet you guys can tell me what the two answers for x would be. Whenever we're working with a quadratic, that's the new unit we'll learn soon, the x squared family of equations, you have two answers. Okay, two answers for x. And right here, it's probably pretty simple if x minus 3 equals 0 to say, oh, well then x must be 3. 3 minus 3 equals 0. X minus 4 equals 0. Oh, then the other answer must be 4. 4 minus 4 equals 0. So it becomes fairly easy once it's factored to figure out the answers to your equation. But when it's unfactored, I have no idea what that would be unless I use my factoring skills. Okay? So that's the whole point of factoring. We're trying to break these back down into smaller, simpler pieces. It's basically the reverse of this polynomials unit you just finished. We're going to learn to go the other direction and break them back down. All right. So here, distributing creates a bigger, more complex expression. We were just doing this stuff, right? We've got 3 terms on the inside, so I'm going to distribute 3 times, and I'm going to end up with that negative 15x3, negative 12x squared, and that positive 21x. The GCF factoring that we're going to learn is going to take this guy and go back the other direction. If I can get my app to work. What if we want to factor it to break it back down? That's what we're going to learn right now, is what if I start with that how would I go the other direction? And what I would do, we're going to learn, I'm going to break down in just a minute for you, is I'm going to look for what I can pull out of each of those three. What's the common factor? And I can see that 7 goes into all of those. So 7 is a common factor to all of them. So I'll just divide the 7 back out. 7 went into 14 twice. So there would be a 2 there. 7 into 21 goes 3 times. And 7 into negative 35 is negative 5. So notice I'm just undoing the distributing. When we're finished, if I redistributed, I'm going to end back up at the 14, the 21, and the negative 35. And then I would do the same part, the same kind of piece, the same idea with the variables. I would say, how many x's can I take out of all 3 of those? In other words, the x has to be common to all of them. And right here, the middle guy only has 1 x. So if I've got to take the same amount of x's from each, I can only take 1 x total. And if I take 1 away from the first one, the x cubed, that leaves an x squared inside. I took the 1 x away from that guy, so there is no x in the middle. I take one of the 2 x's from him, leaving a single x as the final. And now if we distribute and multiply through this, we're going to get that answer. So we just learned how to undistribute our problems. Now let's walk through and learn this piece by piece. Okay. The method we're learning is called greatest common factor, and it's also known as GCF. That's what I'll call it in class, GCF factoring. That's basically the reverse distributing type, where you're pulling out some common factor from all the terms. We're going to start with just the number part of this, and then we'll go to the variables later. We'll take our time building this up so you guys track with me, okay? So if we started with a distributing type problem here and looked at it like this, we'd have 3 times 5, 15, and then 3 times the negative 7, negative 21. So what if we started there and we didn't have this guy to work from? We want to get back to the 3 times the 5 minus 7 in a minute. Let's just get it out of the way so we can see if we can do it on our own. So we need to go for the greatest. That means we're looking for the largest, the biggest of all the factors. You might find a 2, well, that's great, but if there's also a 3, if there's also a 5, you need to find all those factors, put them together, so it's the greatest of the factors. Common means it has to be in all the terms. Right here, we're only working with 2 terms, 2 numbers, so it just has to be in both of those. And a factor, factors are numbers that multiply to make a larger number. Okay, so when we talk about a greatest common factor, I'm just doing exactly, we actually have done this before when we did our radicals in the radical and exponent unit. I'm just breaking down that 15 with a factor tree. It's 3 times 5. I'm going to break down the 21 as well, 3 times 7. And now I'm looking for whatever common factor I can find. Oh, they both have a 3 inside. Sweet. Okay, that's the greatest. That's all there is the 3. It's common to both. So I'm going to pull that out. And that 3 comes out. I'm going to put a parenthesis here. I'm reverse distributing. I'm sucking a 3 out of each of those 2 values, if you want to think of it that way. The 15, once the 3 is pulled out, what's left of him? It's kind of like our radicals. All that's left of the 15 now is a 5, if my pen would work. All that's left of that 21 is the 7. And don't forget your signs, okay? We'll talk more about the signs in a minute, but for now, you can just copy them right down. Make sure that was so negative 21, it needs to stay at negative 7. And notice now, if we reverse to the direction, that's like the check to make sure it works. And it works out. 3 times 5 does make 15. 3 times that negative 7 does make negative 21. And we've factored out our common factors, okay? That's the idea here. Let's just do a little practicing. You guys watch. Let me do a few of these. And we'll work through. 42, 35, okay? I'm just looking for what factors are involved here. There's a 6 and a 7. 35 is a 7 and a 5, so the common factor, they both have a 7. So I would pull a 7 out in front, and then what stays inside the parentheses is the leftovers that wasn't factored out. Okay, there's a 6, and then a 5, and those were both positive numbers, so I'm going to leave them the same signs. And if I want to double check, 7 times 6, 42, 7 times 5, 35, so that is GCF factored as far as just pulling the number piece out. Okay, let's do it again. 24, I could see a 6 and a 4 in there. 18, I could see a 9 and a 2. Now notice I didn't go 6, 3. Just in case we can't see them right off the bat, we still have to keep working. So my 6, I can go a 2 and a 3, 4, 2 and 2. So you can go all the way down into the prime factors if you need to. 9 is 3 times 3, and don't mix these guys up. Those are two different numbers. And the 9 was used, so I'll cross those guys out to not get confusion. And now we're looking for our common factors. I've got a 2 here, and I've got a 2 here. So they both have a 2. And I can pull that out. And then I can rewrite my problem. And what's left inside is these 3 factors, and they all have to be multiplied back together. So out of the 24, I just pulled a 2. So what's left of the 24? Well, it's a 12. You could just divide the 2 out of the 24 and get 12, or you could multiply those remaining factors together. 3 times 2 is 4, times 2 is 12. Either way, we'll get to that 12. Keep your signs the same when you pull things out. And then what's left of that 18 after I pull the 2 out of it is the 9. Now, if we check, we've factored out a 2, and if we reverse the direction, we can see that it works. I just reverse my arrows. I'm going to get the 24 minus the 18, but did you guys catch? Have I done greatest common factoring here? Hopefully you're saying no. Okay. I haven't done the greatest because if we look, 12 and 9 still have another common factor. There's still a 3 that can be taken out. And if we look back up there, we saw that on the original list. Okay. There's a 3 right here inside the 24, a 3 right here inside the 18. And to make it a greatest common factor, you've got to pull everything out. So we have to back up, and we have to do it again to pull out more. We can't pull out just a common factor. We need the greatest common factor. So I'll pull the 2 out, but I'll also, I see a common 3. I'm going to pull that out as well. And all of the factors you pull out, you'd multiply together. So 2 and 3 is actually a 6. That's the common factor. And then what's left after I pull out the 6? Now I see just the 2 remaining 2s, a 4. And check your math here, guys. 6 times 4 should make 24, which it does. 18, if I did this wrong and maybe did a 9 here, I would know that if I checked my work, because 9 times 6 is 54, not 18, so I know I made a mistake. I need to go back and say, oh, I pulled out one of those 3s. I can't use it anymore. I've only got the other 3 left. And now I can check, oh, 6 times 3, yep, that's 18, so now it's correct. So at this point, I've pulled out all common factors because 4 and 3 have no other common factors between them. I've rewritten it, and I'm good to go. That is correct as far as pulling out the greatest common factor. It was a 6, okay? Here's another one, 36 and 18. 36 is, I can think of as 6 and 6. 18, 6 and 3. So they both have a 6 they can pull out. Now, again, if I just go with that, my colors got switched up this time, but that's okay. I think you can track. And bring those down. Do you notice anything about what's left inside? Is there anything else common to a 6 and a 3? There is. So you have to get into that habit of watching and pulling out everything that's common. That 6 can be broken down to a 2 and 3, and then I see, oh, there's another 3 in there. So now, pull out the 6, and pull out the 3. Multiply them all together. So instead of 3 times 6, we'll just write 18. So now it turns out there's an 18 out front because I pulled out the common 6 and I pulled out the common 3, and together they make an 18. What's left of the 36 after I do that is just that 2. This 2 right here. Copy down that negative sign. Now, what happens if I pull everything out of the 18? The 6 and the 3 both got pulled out front. They're gone. There's nothing left of the 18. What I would often see with kids is they would put nothing there. They might end up with this. Say, oh, it's just the 2. That's all that's left inside. But if we did a check and distributed 18 times 2, oh, and by the way, I just noticed I missed my negative. Did you guys see that? There was a negative on the 36, so make sure to copy that to the 2, but my pen isn't working. I can't get that. This darn pen won't work. So it's a negative 2. And if I distribute 18 times negative 2, negative 36, but there's no other term. I didn't have anything else there. There's nothing else to distribute to. So if I check by distributing on my answer, I only get negative 36. I get one term. Instead of 2 terms, the other one disappeared. So that doesn't work. Here's how we fix that. If you have all of something go away, like we just saw, the whole 18 disappears, we have to put a placeholder. Okay, copy as sign. And you put a 1 there. That 1 is the placeholder. Okay, he's there just so that when we do multiply back to verify things are correct, 18 times negative 2, negative 36, 18 times the negative 1, negative 18, and now, yes, it comes back to its original form when I distribute, so now I've done it correctly. If there were 2 terms to begin with, you have to have 2 terms in the parentheses. Even if one of them gets totally taken up as the greatest common factor itself, you've got to leave a 1 there to hold his place so you can multiply back and recreate him later. Okay? All right, one more. 16, 4 and 4. 25 is 5 and 5, and that's a problem. There are no common factors, which means there is no GCF here. If you have no factors at all, you certainly don't have a greatest common factor. You don't have any factors. So you can't do anything. You just have to leave it in its current form, and that does happen at times. You might have a problem without any common factors. That's just how it goes sometimes. So let's have you practice a few of these basic ideas. There's 3 problems for you to try. Go ahead and rewrite them into greatest common factor form so they'll look like a distributing problem. And here's a couple things to help you out. Number 1, find the common factor to both. So do the factor tree and pull out the common factors you find. And then number 2, make sure it's the greatest common factor. You can't just pull out part of them. You got to pull out every common factor. Okay? Check when you're finished. Make sure what's left in the parentheses doesn't have any other common factors. Go. All right, let's take a look, guys. I'm going to see that 30 is a 10 and a 3. And by the way, if your factor trees look different than mine, remember that doesn't matter. It's just seeing the common factors. 6 and 4. And I'm looking now for any common factors. The 3 is going to have, the 3 from the 30, I know will have a common 3 with that 3 inside the 6. So there's one set of common factors. There's another set with the 2 inside the 6. And if I cross out the 10, it was already used up. All I've got left is a 5 out of the 20. And I know there's not a 5 inside of a 4, so that's as far as I need to go. There was a common factor 2. There was a common factor 3, so those both come outside. And what was left inside out of the 30 was the 5. That's all that's left of him. What was left of the 24 is this 4. And I'm going to copy the sign. It was a negative 24 or a negative 4. And there we go. Don't forget to put the 2 times 3 together. It's a 6 times 5 minus 4. And number 1 I check by making sure there's nothing else common. 5 and 4, no more factors I can take out. And then second, I can check by making sure my math worked. 6 times 5 is 30, yep. And the 6 times negative 4, negative 24, yep. So I know I did it right. Now, I'm going to show you what I would say is kind of the quicker version of number 1. You absolutely should walk it out the way I just did it if you're learning the concept and you're having to figure out each of these pieces. But once you get, which is really what you want to be further enough along with your times tables and your factors that I would look at 30 and 24 and think there's a common 6 between them. So I'm just thinking of 6s. There's the common 6, so I'm going to pull it out. And what's left is a 5 and a 4. Copy the sign. Okay, that's how I'm going to look at it. As I get more and more familiar with my factoring and times tables over time, that's how I approach it. Okay, look for a common value between them, pull that out, and then check and see what's left, see if there's any more common factors. All right, let's do the next one. 15 and 35, 3, 5, 35, 5, 7, and I go, whoop, there's my common 5, so that comes out. What's left inside? 3, and notice it was a negative 15, so a negative 3, and then 7, and that was plus, so I leave it there. No other common factors between a 3 and a 7, and if I check it, that makes negative 15, that makes positive 35. I'm good to go. Last one, 28 and 15. That's going to be a 4 and a 7, a 3 and a 5. Nothing common there. I could break down that 4 into a 2, 2, but it doesn't matter. There's no 2s in a 15 either. So I'm done. There is no GCF. That's as far as it can go. Negative 28 minus 15 can't be factored any further. That's as far as that can be taken. All right. I hope this is starting to click for you guys. Okay, here's just a few more examples to kind of expand the idea for you. If I did a 36 and a 48, this could have a lot of small factors in it. Okay, and right there I might be good enough to grab a couple of those 6s. But in case I didn't notice or factored it other than with 6s to begin with, notice if I take this all the way down, there's a lot of numbers at the bottom. That's okay. To keep track, cross out anything that's not a final branch so that you can see what all the finals are. And now, with all these numbers, number 1, keep your 2 trees separate. Number 2, count them all up. I've got 1 common 2. I've got a common 3. I've got another common 2. And that's it. This 3 doesn't have any matches over there, and the remaining 2s don't have any matches in the first value. So notice 2 times 3 times 2, that's 12. And then I would bring in that remaining 3 and the remaining 4 on the right side value. It's a negative in between them. Now I know I've pulled out all those common values. I found all 3 of those final factors that made them the greatest common factor, because there's nothing more that's common between 3 and 4 I can pull out. And then make sure my math worked. 12 times 3, 36. 12 times 4 is 48, negative 48, so I know I'm good to go. Okay, so watch out on problems like that. Make sure you find all the factors. I very often see something factored with stuff still left inside when kids are learning this. Okay, next one. We already showed this, just pointing it out again. 21 and 42, if I was doing this, I would immediately recognize 21 is half of 42. So I know that the way I can go about this, the greatest factor is just to see, oh, 2 times 21 is 42. So I'm going to pull out a 21. 21 is the factor. And all that's left would be that 2 out of the 42. Copy down the signs, But remember, you need something right here. You have to have something right here because you need to be able to distribute and create two terms later. So if you pull out the entire number itself as the greatest factor, that's great. But you got to have something there to hold its place. There still needs to be two terms inside the parentheses, so make sure to use that placeholder 1. Okay? All right, next one. You could have multiple terms. You could have 3, you could have 4, you could have any number of possible terms in an expression or equation that you could try to pull a GCF out of, and it has to be in all of them, okay? Down here at the bottom, all. It doesn't mean you find it in 2 of the 3 and you're good. If you've got 3 terms, any factor has to be in all 3. If you had 4 terms, it's got to be in all 4. So we'll start looking and see what we can find. I've got a 3 and a 7 on that guy. I've got a 4 and a 7 on that guy. I've got a 2 and a 7. Yeah, I kind of made that one obvious, didn't I? They all have a common 7. So the 7 can be pulled out. And what's left is a 3, a 4, that's a negative 4 from a negative 28. I'm going to plus on that guy with 2. And there we go. No more common factors between 3, 4, and 2. You can't pull out that extra 2 between the 4 and 2 because there's no common 2 to pull out of the 3. It has to be common to all of them to pull it out because remember, the whole point is to redistribute in a minute. And if you pull it out of only some but not others, when I distribute all this back out, it's not going to equal your original answer unless all of those multiplying arrows work out. All right, here's your homework. Got a set of problems to factor using GCF. Probably should number those. 1, 2, 3, 4, 5. And then you've got a set of explaining what's wrong with each of these. A, B, C. So somebody solved them. Did they do them correct or not? What is the issue that you see wrong with them? All right. Peace out.